Hello, in today's video we're going to be continuing our discussion on 6-1 angle measure. So as we talked about in our last video, a radian has the following definition. If a circle has a radius of 1 and is drawn with the vertex of an angle at its center, then the measure of the angle in radians is the length of the arc that subtends the angle. So in other words, let's say I have an angle here and it is given in radians. This radius of my circle is going to be 1. If that's the case, then the distance from one point to the next along the circumference of the circle, so right now we are just looking at this length, is going to be the same as that angle measure in radians. So for example, if this angle measure is maybe pi over 4, then the distance from one point to the next, if you were to walk along that little red highlighted region, would be pi over 4 units. The length of a circular arc in a circle of radius r, so now we're saying, okay, maybe the radius isn't 1, maybe the radius is something like 10 or 12 or 30. Then to find the distance along the outside of the angle that subtends that central angle of theta radians is found by our following formula. S is your arc length, and it's equal to r, which is your radius, multiplied by theta, where theta must be in radians. So if our radius is just 1, then our angle measure is the same as our arc length, but if our radius is any other length, then all we do is we multiply our radians by that r value in order to get the distance of that arc length. So for example, we're going to find the length of an arc of a circle with radius 15 meters. So I'm going to draw a circle. My radius is 15 meters. Subtends a central angle of pi over 3 radians. So I'll draw an angle. This is pi over 3, and the question that we are asked to find is the arc length formed by that angle. So all we're going to do is say that my theta is in radians, so S, my arc length, is going to be equal to 15 meters multiplied by my theta, which is in radians, giving me 5 pi meters. So the distance along that red highlighted arc is 5 pi meters. In example B, we have a radius of 27 meters. Now being subtended by a central angle of 30 degrees. Now this is in degrees. What we need is to convert it to radians. So I'm going to go ahead and ask you to pause the video here and finish B by converting our 30 degrees into radians and then finding the arc length and then moving on to C. So we do know that 1 degree is going to be equal to pi over 180 radians, but I've got 30 degrees, so I'm going to multiply by 30 and then simplify. So 30 degrees is equal to pi over 6 radians. So what we're actually looking at is an angle of pi over 6 radians. So S, the arc length, is going to be 27 meters multiplied by pi over 6. And when we reduce, I'm going to get 9 pi over 2 meters. So the distance along this arc that I'm highlighting red is going to be 9 pi over 2 meters. Here we have a central angle of theta. So here is my theta. In a circle of radius 4, it is subtended by an arc length of 6 meters. So now they tell us this length is 6 meters and they want us to find the measure of theta. So I know that S, my arc length, is equal to radius times theta. Well, now my arc length is 6 meters. My radius is 4 meters. What I don't know is theta. So I'll divide by 4 meters on both sides to isolate my theta. And reducing, my units reduce, and 6 over 4 reduces down to 3/2 is equal to theta. So theta is 3 over 2 radians. We're going to move on now into finding the area of a circular sector. So a circular arc just means the distance around the outside of a portion of our circle. Now the area of a sector says we want to know the area of that entire slice now formed by my angle. So we went from a single dimension, just a line, into a two-dimensional space finding an area. So similarly to finding the arc length, in a circle of radius r, the area of a sector with central angle of theta still in radians is area equals 1/2 r squared times theta. So very similar to what we had before, S is r times theta. Here I've got 1/2 r squared times theta, so this might bring you back to areas 1/2 base times height. We do have kind of a triangular region, so that formula should be a little bit familiar. So we're kind of blending our two formulas together. So to find the area of a sector of a circle with a central angle of 2 pi over 3 radians with a radius of 3 meters, I'm going to sketch this out. So I have a radius of 3 meters. And what I want to do is find the area of this sector. They tell me that this central angle is 2 pi over 3 radians. So area of that sector is 1/2 times my radius, which is 3 meters squared, multiplied by my radians, which is 2 pi over 3. So 1/2. 3 meters times 3 meters is 9 square meters, multiplied by 2 pi over 3. 9 times 1/2 is going to be 9 over 2 times 2 pi over 3 square meters, which I can then reduce down to 3 pi square meters. So the area of the sector that is highlighted red is 3 pi square meters. All right, your turn. Go ahead and pause the video and try these couple on your own. Here I have a central angle of 7 pi over 8 and a radius of 4 inches, and I want the area of that sector, so this triangular region or this pie slice formed by that central angle. So my area is 1/2 multiplied by my radius, which is 4 inches, squared, multiplied by my theta, or my central angle measure, which is 7 pi over 8. So 1/2 multiplied by 16 square inches, multiplied by 7 pi over 8. Half of 16 is 8, so 8 square inches multiplied by 7 pi over 8 is going to simplify down to 7 pi square inches. And lastly, find the area of a sector of a circle with a central angle of 135 degrees if the radius is 8 feet. So in order to use our formula, area equals 1/2 times the radius squared theta, theta must be in radians. So I'm going to go ahead and convert. I know that 1 degree is equal to pi over 180 radians. So I multiply by 135 to find that 135 degrees is going to equal the reduced form of this fraction, which is going to be 3 pi over 4. My 135 and my 180 are both divisible by 45, so 135 divides by 45 to give me 3, and 180 divides by 45 to give me 4. So the central angle is 3 pi over 4 radians, and now I can say that area is 1/2 times 8 feet squared multiplied by 3 pi over 4. So A is 1/2 of 64 square feet multiplied by 3 pi over 4. Half of 64 is 32 square feet. And reducing and multiplying, I will have 24 pi square feet. And that brings us to the end of our intro to Chapter 6, Section 6.1 on angles, arc lengths, and areas of sectors. Thanks so much for watching and have a great rest of your day.